Welcome to solverfy.
Okay, so for this problem, you are given a bunch of details, but spoiler alert, I'm not going to write them down because the answer is simple. What's the simplest answer? You can probably guess. So you have a wire that's running like this, and you have current going to the right, and the current is decreasing, and the question is, what is the current induced in the loop? So let's draw the field due to this wire. So the field in the wire causes like a sort of whirlpool type field. So it's kind of coming out and then going in all along the length of the current. So looking another perspective, it's kind of hard to, this isn't like a great representation. So I'm going to try to do a sort of 3D rendering of the current due to a wire. I'm sure there is beautiful graphics made by well-compensated graphic designers. But basically the field kind of has this shape. If this red line is my wire, that this is the shape of the field. And so hopefully through both of these pictures or either, you can get a sense of the field. So great. The field basically, so let's consider what is the flux through this loop, because we're always concerned with the flux, the change in flux through a loop when determining EMF induced. So basically through this wire, like over on this side, if the current's moving to the right, then by the right-hand rule, you have current on this half, you have current going into the page. If we set our area vector of the loop to be out of the page, then that means over here, sorry, I guess, oh, I drew this backwards. So this actually should be, sorry, because the current's going to the right, that should be out of the page and this should be into the page. And so great. And then on this side, there's going to be negative flux. And then on this right side, there's going to be positive flux that's equal and opposite in magnitude to this negative flux, sort of by symmetry, because like it's not like the top of the current above the wire. There's any reason for the magnetic field to be larger or smaller. So by symmetry, the magnetic field above and below the wire is the same, and therefore the net flux is the same. Therefore, the total flux is always zero, regardless of the current, and therefore the change in flux is always zero, regardless of the current. So we can say that this is just always zero. It's not changing.